Right now, as you watch this, two objects are crossing behind the sun, where no telescope can see them. One is burning enough power to light up a continent. The other is wrapped in what looks like a metal shell. For the next 8 days, every major observatory on Earth has been ordered to stand down. No imaging, no radar, no public statements until it's over. Independent astronomers are scrambling to fill the blackout, but the window is closing fast. What happens during those 8 days could rewrite everything we think we know about what's out there. And we're being kept in the dark on purpose. September 12, 2025. The SOHO spacecraft's SWAN instrument picks up something that shouldn't exist. A comet designated C2025R2. Tail stretching 2.5 degrees across the sky, 5 times wider than a full moon. Bright enough to see with backyard binoculars. Within 48 hours, observers in Australia capture it. A streak of light so massive it nearly spills out of the frame. The International Astronomical Union makes it official by September 13th. But SWAN isn't the story yet. 3 days earlier, another object had already been logged. 3I Atlas. The I stands for Interstellar, meaning it didn't come from our solar system. It came from somewhere else, and it's moving wrong. Standard comets brighten as they approach the sun. Predictable. Gradual. 3I Atlas doesn't follow the curve. On July 29th, it pulses brighter, then dims. August 14th, it does it again. Each time the tail shifts color, reddish to neutral, then back. Spectrographs from the Atlas Spec Lab pick up the composition. Nickel, dominant. But here's the problem. There's no iron. Every comet ever studied shows iron-nickel blends. It's fundamental chemistry. 3I Atlas breaks the rule. Then the CO2 readings come in, 5 times higher than water vapor. The exact opposite of what comets do. By mid-September, 2 things are clear. 3I Atlas isn't behaving like a natural object, and it's about to meet something even stranger. Here's where it gets impossible. 3I Atlas enters from Sagittarius. SWAN arrives from Aquarius. Opposite sides of the sky. 2 completely unrelated trajectories. October 17th, Atlas reaches Perihelion, closest approach to the Sun at 203 million kilometers. October 20th, SWAN hits its mark, 150 million kilometers out, 3 days apart. Both objects crossing the inner solar system within 72 hours foreign. Done to 2 hours of each other after traveling for potentially thousands of years. The orbital planes don't match. Atlas comes in nearly perpendicular to the planets. SWAN tilts more than 60 degrees off the ecliptic. If you plot their paths, they're coming from different sectors of deep space. Yet both arrive now. Astronomers ran the probability. For 2 objects of this size and brightness to converge on the Sun within the same week, from opposite directions, the odds sit somewhere around 1 in several billion. Unless the timing isn't random. There's another problem. Between October 8th and 18th, both objects pass directly behind the Sun from Earth's perspective. Total observation blackout. No ground-based telescope can track them. No satellite has a clear line of sight. The most critical 10 days of the encounter happen in complete darkness. And that's exactly when the orders came down. The Atlas Spec Lab released their findings in early August. Peer reviewers immediately demanded a recheck. The spectral signature showed nickel dominating the composition, but iron, the element that should always pair with nickel in cometary material, was missing, completely absent. The lab ran it again. Same result. Then came the acceleration events. 3 distinct pulses, each separated by roughly 2 weeks. July 29th. First acceleration. The object's brightness jumps. Tail shifts from reddish to neutral white. August 14th. Second pulse. Same pattern. Brightness spike, color change, then fade. August 28th. Third event confirmed. This isn't outgassing. Outgassing is gradual. It follows solar heating curves. These pulses came on fast, lasted hours, then stopped. The timing was too regular, the magnitude too consistent. Observers started calling it thrust modulation. The energy numbers made it worse. To produce the observed acceleration, 3I Atlas would need to generate roughly 10 gigawatts of power. That's the output of 10 large nuclear reactors, from an object supposedly made of ice and rock. The CO2 to water ratio added another layer. Normal comets release more water than carbon dioxide as they heat up. 3I Atlas does the reverse, 5:1, CO2 over H2O. The 4.3 micron emission line dominated every reading. Bill Gray, veteran orbital tracker, went on record. The behavior doesn't fit natural models. Something else is driving this thing. The official explanation? Unusual volatile distribution. The data says otherwise. If 3I Atlas is a drone, SWAN is a battleship. The energy estimate for SWAN clocks in at 10,000 gigawatts. That's more power than the entire electrical grid of Earth combined. The tail alone stretches 2.5 degrees across the sky, the largest observed in decades. But it's not just size, it's what's inside. Reflectance data shows something metallic. Not ice, not rock. The spectral signature matches nickel-cobalt alloys, materials engineered for strength and heat resistance. Amateur spectroscopists started noticing a pattern, a silvery halo around the nucleus, shifting, pulsing. The shape changed with solar wind pressure, like it was deflecting particles. Some called it a plasma envelope, an electromagnetic shield. Then came the micro-thrust observations. High-resolution tracking caught tiny directional changes in the tail. Small bursts, rhythmic. The photometric curve showed brightness fluctuations synced to these pulses. Each one lasting minutes, repeating in patterns. This isn't random outgassing. Random doesn't repeat on a schedule. The orbital data sealed it. SWAN's path takes 22,554 years to complete one loop. The last time this object passed through the inner solar system, humans were living in the Ice Age. Glaciers covered half the northern hemisphere. Yet here it is, arriving within 3 days of 3I Atlas. Both objects crossing the Sun during the exact same blackout window. SWAN doesn't just dominate by scale. It dominates by design. The metallic signature, the shielding, the precision thrust control, the impossible timing. If Atlas is a scout, SWAN is the payload. And both are about to disappear behind the Sun, where no one can watch what happens next. 3 scenarios fit the data. First, refueling. Both objects use the Sun as a power source. Solar magnetic fields for recharging. Energy collection. Data transfer between units. The Sun becomes a pit stop, a scheduled maintenance run. Second, intervention. One object malfunctioning, the other sent to recover it, or terminate it. The power difference supports this. SWAN at 10,000 gigawatts, Atlas at 10. One's built to enforce, the other to comply. Third, escalating response. 2017 Oumuamua passes through. No reaction. 2025, Atlas arrives. Then, SWAN. Each visit bigger than the last, each one a stronger probe checking what triggered the alert. A century of radio signals beaming into space. Nuclear detonations lighting up atmospheric sensors. Maybe someone finally noticed. All 3 theories share one anchor point. The Sun. Not just background. The Sun is the destination. The blackout window isn't an accident. It's the moment both objects need to complete whatever they came here to do. And we're locked out. 22,554 years ago, SWAN last crossed the inner solar system. That puts its previous visit around 20,000 BCE. Deep in the last ice age, glaciers covered Europe. Sea levels sat 400 feet lower. Human civilization as we know it didn't exist yet. But something was happening. Ice core samples from Greenland show chemical anomalies in layers dating to that exact period. Sudden dust deposits, atmospheric changes, events that line up with major celestial activity. Then there's Göbekli Tepe, built 11,000 years ago in what's now Turkey. Massive stone pillars carved with animals and symbols. Some researchers argue the carvings map celestial events, comet paths, objects tracked across generations. The cycle is too precise to dismiss. SWAN returns exactly when human culture begins emerging from the ice. Not random, not coincidence. If this object is on a programmed route, it's been running longer than recorded history, longer than agriculture, longer than writing, and it arrives now. October 2025, during a blackout, alongside another visitor that doesn't follow physics. Someone set this clock 22,000 years ago. It just went off. October 8th through 18th. Official designation, solar conjunction downtime. The explanation sounds routine. The sun blocks the view. Telescopes can't observe. Standard procedure, except the orders go further. Internal memos from U.S. Space Command and the European Space Agency direct teams to suspend all radar tracking of both objects. High-resolution imaging requests denied. No explanation given. Proposals for alternative coverage using radio telescopes? Rejected. Data requests from independent researchers? Delayed or rerouted. Several allocation reviewers, speaking off-record, describe explicit orders. No public statements about either object until after Perihelion. Bill Gray didn't wait for permission. He rallied the amateur networks, the Ibero Tracker Collective in Spain, backyard astronomers across Australia, small observatories willing to go off-grid. The call went out across forums and encrypted channels. Keep your scopes on the sky. Log everything. Share the raw data before it disappears. With government channels locked down and major observatories silent, the grassroots effort becomes the only eyes still watching. If you have a telescope, a radio dish, access to tracking software, you're part of this now. The blackout window is closing. Both objects re-emerge in less than 48 hours. Whatever happens behind the sun, the first signal might not come from NASA. October 20th, Perihelion. Both objects at closest approach. The amateur networks are tracking exit trajectories now, waiting for the first post-blackout images. If SWAN and Atlas emerge unchanged, the refueling theory holds. If one doesn't emerge at all, we'll know this was an intervention. And if both objects alter course after the encounter, the data's coming in. Right now. Live feeds hitting the forums as observers across the southern hemisphere pick up, wait, something's wrong with the trajectory.